Alright, so now we're going to continue with lesson 11.5. So here we're going to talk about density. So they give a great definition. Density is the amount of matter that an object has in a given unit of volume. So that's how this relates to this lesson because we're talking about volume. So the density of an object is calculated by dividing its mass by its volume. Okay, so that's our formula. So you can kind of abbreviate it as D equals M over V. And I know you're a little bit young for this, but eventually you'll go to the DMV to get your license. So the driver's or Department of Motor Vehicles is what it stands for. So, but the driver center. So anyways, so that might help you remember it. But different materials have different densities, they go on to say. So density can be used to distinguish between materials that look similar. So they talk about table salt and sugar. They look alike, but table salt has a density of 2.16 grams per cubic centimeter, while sugar has a density of 1.58 grams per cubic centimeter. So it helps us differentiate things beyond their look. Okay, so let's go ahead and use this formula for density. So this diagram shows the dimensions of a standard gold bar at Fort Knox. Now gold has a density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. Okay, so they're giving us a couple pieces of information. Let's figure out what it is we have and what we need. So here's density equals mass divided by volume. Okay, now just let's point something out. They tell us here that the density is 19.3 grams per cubic centimeter. So the units for density are grams per cubic centimeter. Well, guess what? That relates because our mass is going to be in grams and our volume is going to be in cubic centimeters. So we have correlating units, which is how a proportion needs to work. So all of that lines up. I'm just going to get rid of those so that we can go ahead and fill in what we know then. So the density I can replace with 19.3. They want us to find the mass, so I do not know the mass, but I can calculate the volume based on this picture over here to the right. Now the interesting thing is they want it in grams per cubic centimeter. Okay, now when I look at this bar, it's in inches. So that's the reason that I've written in here 1 inch is proportional to 2.54 centimeters. So what we're going to do is we're going to go ahead and multiply each of these by 2.54 to figure out what their centimeter length would be. So 7 times 2.54, and I'll just write that so you see what I'm doing. 2.54 is going to give us 17.78 centimeters. And then 3.625 times 2.54 is going to equal 2075, and that's in centimeters. And I know that I've been rounding to the nearest hundredth. If I see a number that's not that much longer, like this one, it only goes out to the 10,000s, I'm going to multiply it like we did there. Okay, so next we have 1.75 times 2.54, and we get 2.54, and my answer up here is going to be 4.445. Okay, so using these numbers, and that's centimeters as well, I can find the volume in cubic centimeters. So 17.78, 9.2075, and 4.445. Okay, if I multiply all these together, I get 727. Now here I am going to have to round because it is just way too long. It looks irrational to me, but it might actually end up stopping. Anyways, 727.69 cubic centimeters. So I can put that in this spot. And I'm going to multiply both sides by that value, and I'm going to end up getting that mass, if I multiply that number by 19.3, is equal to 14,044.38, And this is going to be, they're asking for the mass, so I'm just going to write grams. And that's my answer. Okay, so the problem involved a bit much just because we had to do the unit conversion, but beyond that, it wasn't that bad. Hopefully you felt the same. Okay, all right, let's go ahead and do the next one. Now, if you rounded differently, possibly you have a bit of a different answer, okay? So if you had rounded somewhere else within the problem, yours might be off by a bit, but again, if we can save the rounding to the very end, that's most helpful. All right, the diagram here shows the dimensions of a concrete cylinder. This concrete has a density of 2.3 grams per cubic centimeter. Find the mass of the concrete to the nearest gram. So same thing, density is equal to mass divided by volume. They tell us the density is 2.3. We're trying to solve for mass. We need to find the volume. So the volume of this cylinder is going to be pi r squared h. They want it to the nearest gram, and they give us our density in grams per cubic centimeter, but again, these are in inches. So my first step to make sure we're not doing anything complete, all the work and then having it be wrong, is I'm going to multiply each number by that 2.54 that we saw right up here. Okay. So 32 times 2.54, oops, typed it in wrong. It's going to give us 81.28, and this is centimeters. And then 24 times 2.54, it's going to equal 60.96. Okay, so now when I do the formula, it's going to be pi times my radius, 60.96, squared times the height of the cylinder, which is 81.28. All right, so I'm just going to type all of that in, and obviously well, actually, I'm going to hold off on multiplying by pi. So here's what I mean by that. I'm going to do 60.96 squared and multiply that by 81.28. I'm getting a long number. 302046.36. And then 36 again, so possibly that repeats, but I don't know. And then I still have that pi in there. So like I said, if I can avoid rounding as much as possible, that's good. When you guys get to science, I believe it'll be 9th grade, if I haven't already shared this, you'll talk a lot about significant digits so that they recognize that the rounding alters your answer. But by doing this, I just pull that number over there. I still have this up on my screen. So now what I'm going to do is I haven't deleted my answer and rounded it to 0.36. I still have the full answer on my screen. So now I'm going to multiply that by pi, and I'm going to multiply that by 2.3. Because what I would do at this point is multiply this by 302,046. I would multiply this side by that number, and I would multiply this side by that number too, right? And hopefully, oopsies, there it goes again. 302046.36 pi. And that's what those cancel. So that's how I'm getting the mass is going to equal. All right, my answer is 2184. Oh, let me reverse that. I'm going to get 26527, and this is in grams. Okay, so that gives me an answer of, ooh, big, 2,182,485.265 grams. Okay. All right, let's move on to the next part. Now what we're going to do is just a little bit of filling in the blanks. So we're building a rectangular chest. We want the length to be 6 feet, the width to be 4, and the volume to be 72 cubic feet. What should that height be? So this is my unknown. Because it's a prism, I can do the area of the base, or I can just do length times width times height. So that's going to give me 6 times 4 times h has to equal 72. So 72 is equal to 24h. And if I go ahead and divide that, I'm going to get that h is equal to 3. Okay, so the height is 3 feet. That one wasn't bad at all. The next one, you're building a 6-foot tall dresser. So we can kind of think of, oops, wrong line. 6 feet tall. We want the volume to be 36 cubic feet. What should the area of the base be? So in this one, I'm going to write capital B times H, the area of my base. They give us the volume. We don't know the area of the base, but I know the height is 6. Give a possible length and width. So if the area of this base is 6, it could be 1 by 6. We can have 1 foot by 6 feet, which if it's a dresser, that's reasonable. We could also do a 2 foot by 3 foot. So those are my options. Okay, so just kind of thinking real life terms. Now we have one new concept left that pulls on some familiar things, and this is similar solids. So two solids of the same type, meaning they're both cylinders in this example, with equal ratios of corresponding linear measures, such as heights or radii, are called similar solids. Okay. So the ratio of the corresponding linear measures of two similar solids is called a scale factor. We've actually talked about this. If two similar solids have a scale factor of k, the ratio of their volumes is k cubed. We actually did this before, but not with volumes, obviously. So if we want to remember, we always do image over pre-image, or we thought of that as new over old. Right? Now they're not telling us which is going to which. I'm going to assume that A is going to B, although it would work reverse because it's just a proportion is how we set it up. So what I can do is I can say that the volume of cylinder A, or I'm sorry, we'll do the new one. Sorry, the volume of cylinder B, which is my new one. So I'm going from here, that's my original, to here, that's my new. So the volume of cylinder B over the volume of cylinder A is going to equal what they tell me here, k cubed. Okay, so what I can fill in is that I don't know the volume of cylinder B, that's not given to me, that's unknown here, but I do know the volume of cylinder A, 45 pi, and if I look at the ratio is my scale factor. Well, what's happening? It multiplied by 2, so this is going to be 2 cubed. So I get x over 45 pi is equal to 8, and obviously the only thing I need to do then is multiply both sides by 45 pi. That cancels, and I find that x is equal to 360 pi centimeters cubed, and I can leave it like that because they left their volume as pi. Okay, so let's set up another one just like that. Whoops, too far. So here, prisms C and D are similar. They tell us how to find the volume of prism D. So I'm going to take it that this is my original, this is my new. So I can say the volume of my new, which is prism D, over the volume of my original, which is prism C, is going to equal the scale factor. So if I look at a comparable side, 12 turns into 3. So my scale factor here is getting smaller, so it makes sense it's going to be 1/4. Okay, and that's the k cubed. It's equal to k cubed, the scale factor cubed. So the volume of prism D, I don't know, it's x. The volume of prism C is 1,536 meters cubed. I don't need to put meters cubed though. All right, and that's equal to, this cubed is going to be 1 over 64. So what I'm going to do is I'm going to multiply this side by 1,536, this side by 1,536, those cancel, and I'm going to get an answer of 24, and I will label it meters cubed. So my volume is 24 meters cubed, and if I look at that, it looks reasonable. Okay? All right, we are close to the end. I just want to take a look at the setup here. So if we want to define the composite, when they say composite solid, it means it's made up of a couple of things. So they're finding the volume of the concrete block. So we're going to find the volume of the large block, and we would subtract from it the two smaller ones. So I actually already have that. It's going to be 0.570636 minus, and then each small one is 0.084942. And then if I just calculate that out, you get this number. So that's about 0.4 cubic feet. Just rounding it. Okay, now the next one, same idea. Sometimes you have to do combination. So you would find the volume of the triangular prism and subtract the volume of the rectangular prism. Okay? All right. See me with questions. Great work, guys.